Most of the electrical energy that's used in homes, businesses, and in industry is supplied from an electrical generating plant. And that electricity travels to those locations through solid wires. But the question is, how can electricity flow through a solid wire? The answer lies in the atomic structure of matter. Matter is anything that has weight and takes up space. Matter may take the form of a gas, solid, or liquid. All matter is made from different combinations of nature's building blocks, known as atoms. If a drop of water were broken down into its basic elements, there would be 2 atoms of hydrogen and 1 atom of oxygen. All atoms contain 3 types of subatomic particles that are of interest to you in electricity: neutrons, protons, and electrons. The neutrons and protons in an atom are about the same size and weight, and they form the nucleus. Modern physics has shown us that neutrons and protons are not solid particles, but rather made up of 3 subparticles called quarks. The nucleus always contains 1 or more protons, and may or may not contain neutrons. For example, hydrogen has only 1 proton in the nucleus. Helium has 2 protons and 2 neutrons. And carbon has 6 protons and 6 neutrons. All protons are alike, all neutrons are alike, and all electrons are alike. The difference between one kind of atom and another is the number and arrangement of the protons, neutrons, and electrons. There are over 100 different kinds of atoms, and they're listed in the periodic table of the elements. Electrons are much lighter than neutrons or protons and orbit around the nucleus in much the same way that planets orbit around the sun. The proton has a positive charge, and its symbol is a plus sign. The electron has a negative charge, and its symbol is the minus sign. The neutron has no charge, and therefore has no sign. The negative charge of an electron is equal but opposite to the positive charge of a proton. These opposite electrical charges create an electrostatic field. An atom is balanced when it has an equal number of protons and electrons. It has no charge, and it's said to be neutral. When an atom has more electrons than protons, it has a negative charge and is called a negative ion. An atom that has fewer electrons than protons will have a positive charge and is known as a positive ion. The law of electrical charges states that particles with like charges repel each other, while particles with unlike charges attract each other. Protons repel each other. Electrons repel each other. Protons and electrons attract each other. Electricity is produced when electrons are freed from their atoms and are moved from atom to atom by the attraction and repulsion of protons and other electrons. This movement of free electrons is known as electron flow. When a large number of electrons flow from one atom to another in one general direction, an electrical current is produced. To measure the current flow, the number of free electrons moving past a point in an electrical circuit is counted per unit of time. Just as an ounce is a basic unit of measurement for liquids, the coulomb is the basic unit of measurement for electricity. It takes 6.28 billion electrons to make 1 coulomb. Electric current, or the rate of electron flow, is measured in coulombs per second and is better known as an ampere. 1 ampere of current is the flow of a coulomb of electrons per second past any point in an electrical circuit. To simplify the writing of measurements in electricity and electronics, units of measurement are always abbreviated to a single letter and follow a standard form called the International System. Sometimes the unit is named after a person. Therefore, the ampere, named after the French mathematician André Ampère, is abbreviated as a capital A. The coulomb, named after Charles Coulomb, is abbreviated as a capital C. For example, 5 amperes is written as 5A, and 5 coulombs is written as 5C. Symbols are another shortcut used to identify what's being measured. For example, electrical current is shown by the symbol I. Therefore, a current flow of 5 amperes would be written as I equals 5A. So, using the symbols, I equals A equals C per second.